This is section 1.6, transformations of functions. If you'll start by opening your book to page 205, there are several graphs, 7 of them, of what we call parent functions. These are graphs that do not have any shifts or translations. And we talked about parent functions last year. So you should know these basic parent functions on page 205. The constant, the identity, which is the linear, absolute value, quadratic, square root function, cubic, and cube root function. So you should be familiar with all of these parent functions. First transformation, we're going to look at our vertical shifts. This is when we add a number to the end of the equation, and that shifts the graph up. When we subtract a number at the end of an equation, we shift the graph down. You're familiar with this. For example, if we have a function f of x, which equals x squared, and using some function notation, if the graph of g of x is f of x shifted up 2 units, we would write g of x as x squared plus 2. So if our original function is the parent function of the parabola, and then we take and write a new function, g of x, which has shifted up 2 units. It's simply the same graph with a different y-intercept, same as shifting down. Horizontal shifts. If we add a value inside of the function, this is a little bit harder to see, but we've done this before as well. Or if we subtract a number, this graph does our shift to the left or right. This is like our, well, let me back up a minute. This is what we would have called our HK shifts. This would have been our plus K in our textbook last year. And this would be our H. We always had X plus H inside of the function. And if you remember, this works the opposite. So X plus H or X plus C shifts to the left, whereas x minus c shifts us to the right. So again, if we have a function f of x equals x squared, and we want to shift this function to the left, and we're going to shift it to the left 1 unit, that would create the function x plus 1 squared. And if you FOILed that and graphed it, again, this would take our parent function and move it to the left 1 unit. So HK shifts, which you're familiar with from last year, x minus h plus k, that should have been a minus, sorry. The minus h does the opposite. This is the right and left shift inside the parentheses, and the k, which comes after the function, is our up and down. So HK shifts, you're familiar with those. This textbook just uses a little bit different notation, but it's all the same thing. Don't worry about it. Reflection around the x-axis. If I take a function and put a negative in front of it, then every value from the original function becomes a negative. In other words, if we have y equals x squared, and let's use the f of x again. If I have f of x equals x squared, and our g of x is going to be that function with a negative in front of it, you can see that what we have done is taken our parent function and reflected it around the x-axis. Every y value that was positive now becomes negative. And we've called these reflections in the past years, and it's simply putting a negative sign in front of the function. We can do this with an absolute value function. If we do the transformation, it does the same thing as our parabola. The parent function looks like this, and the transformation flips over the x-axis. Now, reflection around the y-axis is a bit different. And this is what we're talking about with even and odd functions. If every x value is changed to a negative, but the y value remains the same, then we rotate around the y-axis. So again, using our function notation, if f of x equals x squared, and g of x is a reflection of that around the y-axis, you can see that in this case, the function remains the same. If I have this function, oops, that should go through 0, 0, and I spin it around the y-axis, I hope you can see that that's not going to change at all. It's just going to rotate and fall back on itself. Let's look at a cube root function, which will be a little bit more obvious for this. So if I have f of x equals x cubed, and then I want to take g of x as the reflection around the y-axis of f of x, if I change x with negative x, now the signs will change. My regular x cubed function is a function that looks like this. If I take the reflection of that function, let me change ink colors, now my function rotating around the y-axis will look like this. So reflection around the y-axis, again, instead of putting the negative sign in front of the function or the y values, we're going to change the x values to negatives. These are all reflections that we have looked at before. We've also looked at vertical stretches or shrinks. And in our text last year, that was the a value in front of my function. So this would be our stretch or shrink vertically by placing a coefficient in front of the function. If this notation is confusing, please just look through the textbook and think about the notation we've used in the past. It's not a big deal. So again, if f of x is x squared, and we want to stretch that function to create a new function g of x, and let's say we're going to multiply it by 2, we now get 2x squared, and again, remembering from last year, if our parent function looked like this, then the function with a vertical stretch would look like this. And we can do the same thing with a shrink. If that a value or c value is a fraction, like 1/2, that does a vertical shrink. So this is if a equals 1/2, and the other was if a equals 2. Horizontal stretch or shrinks do the same thing, but again, we multiply inside the function value. So for example, if we have f of x equals the absolute value of x, and I want to create a horizontal shrink by taking f of cx, that would be like putting the 2x inside. I know that this was quick. Most of these transformations you've seen before. If you look at page 213, oops, sorry, let's back up. Page 213, there is a chart there that summarizes all that we just talked about. Again, with the notation being different than what you looked at last year, it might be less confusing just to think of our A, H, K shifts, where A is our vertical stretch or shrink, H is a horizontal stretch or shrink, or excuse me, horizontal shift, K is a vertical shift, and the new one is that instead of placing the A value outside of the function, if we change that to inside, which we didn't look at a lot last year, but we'll look at this in class, then you can see that it's going to do a horizontal stretch or shrink rather than a vertical. I want you to take a minute and take a look at example 7 in your book. Let me see if I can get a blank screen here. Example number 7 in your textbook. And in this case, what they are doing is they are using a graph that may not even have an equation, but they're applying the stretches and shrinks to it. So you can see that the original graph, which is in figure 1.59, and that's the function that they are going to be calling f of x. And then in the graph at the bottom, you can see that they have taken this graph and done a horizontal shrink. So they have taken and moved everything in so that the graph has gone from a wide-based graph, looking something like this, and they've moved everything in. So when this was at 4, they've moved it in, and now it's at 2. You can see that the vertical doesn't change. It goes down just as far as it did before, but it's been pushed in 2 units. And the same with this function up here, where this was -2, 4, excuse me, not 2 units, but in half. This has been moved to -1, and this that was at -4 has been moved into -2. So it's been cut in half by doubling the value inside the function. You might want to look at example B at the top of the next page and see that for this case they have stretched it or made it twice as big going in either direction. If we have multiple transformations, this is the order that we want to do them in. The horizontal shifts should be done first. Then we should stretch or shrink horizontally again. Then we should do any reflections, those are the flips. And then finally vertical shifts up and down should be done as well. So again, take a moment, turn off the video, look at example 8 in the textbook, and see what you can do with that.